If k and 1 upon k are the roots of the equation ax square plus bx plus c is equal to 0, then the roots of the equation 4cx square minus 2bx plus a equal to 0 are. So this is the equation and roots of this equation are given as k and 1 upon k. So from here I can write two things about this equation, sum of the roots and product of the roots. I know sum of the root k plus 1 upon k is minus b upon a. This is sum of the root, and product of the root I know is k into 1 upon k, that is 1, is equal to c upon a constant term upon coefficient of x square. So it is c by a. From here c is equal to a. I get c is equal to c as equal to a, and sum of roots, that is k plus 1 upon k, is equal to minus b by a. Now I have to find the roots of this equation. From here I know c is equal to a. Now let's just assume the roots to be alpha and beta. I know sum of root of this equation will be minus b by a, that is 2b upon 4c, 2b upon 4c, and product of the root alpha into beta will be how much, a upon 4c. From here I can replace c as a. So if I place c as a, it becomes a upon 4a, because c is equal to a from here. So it becomes alpha into beta, or the product of the roots of this equation will be 1 by 4. Check the options. Which option satisfies that product of the root is 1 by 4. So if I multiply these two roots, it is k by 2 and it is 1 upon 2k. So the product of the root is 1 by 4. Yes, it is satisfying. Minus k by 2 into minus 1 upon 2k. It is also satisfying. Product is 1 by 2. 2k into 1 upon 8k. It is also satisfying. 1 upon 4, and minus k by 4 into minus 1 upon 4k. It becomes how much? 1 upon 16, which is not satisfying. So option D cannot be answered, but there are three options which are satisfying this condition, that product of the root is 1 by 4. So I have to check for the sum of the roots. I know sum of the root is 2b upon 4c, or it will be equal to sum of root of this equation will be b upon 2c, or replacing c as a, it will be b upon 2a. So I need to check the options first. Option A is when roots are k by 2 and 1 upon 2k. When roots are k upon 2, k by 2 plus 1 upon 2k. So I am just adding to get the sum of root. Sum of root will become how much? If I take half as common, it will become k plus 1 upon k, and k plus 1 upon k I know is minus b by a. So it will become minus b upon 2a, which is not the sum of root. I have found out sum of root as b upon 2a, and it is minus b upon 2a. So a cannot be my answer. Let's check the option B. If roots are minus k by 2 and minus 1 upon 2k, and I am adding these two roots to get the sum of the roots. So sum of the root in this case will become, if I take half as common, it will become k plus 1 upon k. K upon 1 plus k is minus b by a. Minus b into minus 1 is b by a. So it becomes b by 2a, which is indeed satisfying the condition which I got earlier, was that sum of root is b by 2a. So in this case, if roots are minus k by 2 and minus 1 upon 2k, sum of root comes out to be b upon 2a, and product of the root is 1 by 4 in this case. So correct answer to this question is option B.